first in, first out, you look back, okay, the past. So long old one will be written. But in optimal solution, you will see future. When this one will be used? Next time. 2 will be used here. And 3 will be used here. 4 will be used here. So which one do you want to keep? 1 will be used next time. So I want to keep. 2 will be next. But 4 is the longest the time among the pages. So 4 will be replaced by 5. Okay? Then 1 is here, 2 is here, 3 is here, 4. 4, in this case, 5 will be used here, the next, so would like to keep it. One of them, whatever. Okay? So we select the first one. Then it doesn't matter how many pages for. 1, 2, 3, 4, 5, 6. It's better than first in, first out. It makes sense in random. Okay? So that is the optimal algorithm. It's the same thing. Why don't you apply the same thing for the other reference string? So how many? 1, 2, 3, 4, 5, 6, 7, 8, 9. It was 1, 2, 3, 4, 5, 6. Was it 15? So much better. Okay? So it's usually good. There is a huge problem of using this one. What can be the problem?
More costly?
Costly? Even though it's costly, I'd like to use this one. Because optimal. What will be the problem? It has a huge problem when you implement this.
The future must be predicted.
Yes. How do you know? In future, whether this one will be used or not, this one when it will be used, we don't know. So that is a huge problem. So to address that problem, as he mentioned, we need to practice. Is it possible? Yes. Why? So program is not just a bunch of instruction code from just the beginning to the end linearly. No. It has a routine and it has a pattern. So if we can understand such a pattern, we do not know, there's no way exactly the future instruction or the reference code, but we can assume or the guess or predict such a future, but it's not easy. So that is the problem of the optimal solution. So sometimes this optimal algorithm used for reference, okay, algorithm, which means I have a new algorithm, okay, then I'd like to compare with the optimal, how much the get close to the optimal solution, okay, for reference. So if we apply the optimal solution to the another reference string, why don't you try, okay? Nowadays, I have seen a lot of, I got several students who asked me what is the best way to recover your midterm exam. So please start hard for your final and the project. So do not believe too much the understanding. Until you did by yourself, you do by yourself solve the problem on your hand, I don't think so it's yours. Okay? Please solve the problem with your own hand, please.
It's good. It's good. So we
Yes.
actually studied a lot for the for the meantime, but we had
Yes.
a lot of I had chapter 1-6 to
Mhm.
go already, so it's quite fast.
Mhm.
So what I would suggest, probably can give us more detail.
For the final exam, you mean?
Yeah, for the final we give more detail, but for the midterm,
Huh?
I know I studied a whole lot, but
Mhm.
the outcome wasn't so good because I had a whole lot to study and I'm like, I don't know where to go.
Mhm.
So maybe
So
details
this way
about their-
is the textbook. Okay?
Yeah, the
Yeah.
textbook is very big.
Yeah, very big. That's true.
It's a very big textbook.
Very big.
And there's no way I could cover it. Because actually have other subject, projects and
There's
everything.
no easy subject. Okay?
Yeah, so I was just
Yeah.
suggesting maybe for the final we have more,
It's
more
the same
detailed
le-
tips. Because of more tips.
What?
More structure, like
Mm,
we're reading like 9 chapters, but
yeah.
we're consuming all this stuff, but half of it is not even on there. We're studying more
So,
on one
If
side.
I were you, I will take the topic only from the slide and our lecture. Then starting with the textbook, which means, so probably I didn't cover the line by line from the textbook, but some of the part I emphasize on at that time. Many of the students too much rely on the text in the PPT file. I don't think so. Okay, so please at the time study. Even whenever I come to the classroom, I read it again. Even though I read them many times, I read it again. Whether I miss the part, I read the textbook. Okay. So textbook is the best way, even though that is 100 pages, 200 pages. Okay. Okay. That is the best way.
Can you give us like important topics or guideline? For
Yeah,
studying?
guideline, that's what I'm saying, guideline.
Guideline.
Maybe you can tell us.
But if I give such a guideline, because if I can give the details of the guideline,
No, not too detailed. but-
then that makes the problem. Because probably the final exam will not be guided by only the guideline. Okay, and many of the students rely on the guideline. They complain a lot later. Or when they study, I can do only this one. So I don't think that's a good idea. Because I did the same thing, I allowed the cheating sheet, even the classroom, because I had a struggle to memorize each and every definition and algorithm. So because I understand the difficulty to memorize all the things, I gave the chance to write down what you missed, what is sometimes difficult, what the details of the algorithm. The problem is, usually the average score of the exam that allow the cheating sheet is less than without cheating sheet. Because you too much rely. There is no real way in the study. That's true. Okay? If you difficult to learn, it's the same thing to the other student. I definitely consider the curve, apply the curve, okay, when I decide the final exam. So if you are better than the average, I think that's good. Even though you got the 60 does not mean the fail in this class. Okay. Also, it has been for a while for me. What is the overall performance of the student in the operating system class? Because it's for a while. So I know the midterm is a little bit tough, but you don't have to be depressed. But if your score is below the average, that's a problem. Okay, then you need to work hard, definitely. But all of the student is above then I expect that there is a chance. I do not apply the curve that the move down. Okay, so usually the shift up. So that is the best way. Also, from time to time in the classroom during the lecture, I focus on certain part. You can give more time to understand such a thing. And also, the multiple choices. Please read carefully such choices. You probably realize. So the example of such a multiple choice, I do not make by myself. Mostly it's from the textbook or the literature existing. So which means if you read the textbook, truthfully, then you can answer. But I don't think you are very serious to mark the multiple choice. Okay? Mostly one or two of the choices are obvious case. then you need to decide the other two. Okay, then the LRU algorithm, recently used algorithm. At this time, we'd like to take a look at back, okay? Past, that makes sense. Comparing to the see the future, okay? However, this time we will see we will decide the victim for the least recently used one, okay? That has not been used the longest period of time. So we will use the same reference frame with a 4-page frame. So 1, 2, 3, 4. Then 1, 2, there's no problem. So we have so far 1, 2, 3, 4, page 4. Then 5. When we see the 5, okay, which one will be written?
Three.
1 is used this time, right? 2 is used this time. And 3 has been used this time. And 4 is used this time. Which one is the least used one? 3. It's different from the first in, first out. First in is which one is the longest time to enter the page frame. Okay, this one, first in. But this time, when is the last time to be referenced? So this is the LRU at victim according to the LRU. So page 4 and this will be 5. Similarly, 1, 2 is already here. So then 3 to decide the victim. There's no, it's a page 4. So 1 has used here, 2 used here, 5 used here, and 4 used here. So this one is the least recently used. So replace. Then 4. No. So we need to page 4 again. So 1 is used here, and 2 reference here, and 5 here, and 3 is here. So 5 will be beaten. Similarly, 5. So we need to find this one is the least recently used. How many 4? 1, 2, 3, 4, 5, 6, 7, 8. It's not better than the optimal, but it's better than the first in, first out. Okay? So that is the least recently used one. The problem? Who decide? How to decide? How do you manage? You need to manage when it is the page was referenced. Okay, you need to separate. You don't want to take a look at all of them. The first thing, you know, when it's not changing, but the reference type is changing whenever it's referenced. So you need to manage separate spaces. So it's more costly. So it needs overhead, space and time. This is one of the way how to implement LRU algorithm. The previous one just explained how the LRU algorithm is working. Okay. For the implementation issues, where is it? For the implementation, it's a different story. We need the space, we need the time. So for the space, so this time we can use the counter. Counter is the instruction, the hardware instruction that the increment the value. So for each page frame, we will assign the one counter. Okay, so keep it. Whenever it's a reference is set as 1, then increase. Whenever there is the next reference page. So for example, 1, 2, 3, 4. So this is a 4. This is a 3. This is a 2. This is a 1. Then when you design the victim, like this one, page 4, you can see because 1 is referenced here, so 2 and it's 2 is referenced here. It's not the page 4. page 4 is here. So you can take a look at this the counter. So which one is the oldest one, least recently used one? So highest counter. Okay? So you don't have to check back all of this, just so you can see this counter information. But you need additional space. You can save a time, but you need the additional space. This is in terms of algorithm, it's the same result, 884, but it's implementation issues. Another way is we can manage the stack. We can use the stack. Okay? Stack is first in, last out, right? So which means if we have the stack like this one, or if this one is a reference, it will be the stack in. Then 2 will be stack in, which means which one is the oldest one? The bottom one will be oldest one. And whenever they are referenced, it will move to stack out and stack in again. Okay? Then, so in case of page 4, like this one, which one will be victim? The bottom one, right? The 3 will be victim. You don't have to use the counter for each, just one data structure stack is needed. Okay? So this is the idea. And in terms of algorithm, it's the same result, but the different implementation. So this is based on the stack for LRU algorithm. Okay. So next class, we will continue. I think it's the same thing up to this one. Use, we will start from here, the most recent reference. It's a step. I think it's the same thing. So from the LRU approximation. By the way, that is the same as you mentioned, that is the preemptive shortlist job first is the same as shortlist the remaining job first. It's mentioned in the textbook. Okay? So I think you can check it again. And also the slide it shows.